Hello everyone, my name is Sona and it is my honor to present the Universal Test Frame. Before we get started, I want to say a special thanks to SUNY Paltz for providing us with the resources to execute the design of this project. I would also like to thank Dr. Nelson for his contribution and the honor of his guidance through the whole process. So our design consisted of a frame as seen here that we wanted to construct for an Instron machine. Now, what an Instron machine is, it pretty much applies vertical loads, such as seen here. For example, this is a beam, and the Instron machine would apply a vertical load on certain structures. And that's why we wanted to create this particular frame. Now, we knew throughout the design process that we would have to use certain principles and theories that we learned throughout our engineering careers, such as statics, delving into axial stress, force moment stresses, bending stresses, and other torsional stresses that would be experienced by the frame itself. Now, before we got to the final design, we went through several design iterations as seen on this right side right here. Initially, we wanted to construct a frame using welding, but knowing that the resources were scarce for welding and the design team had no experience with welding, we chose to forego that particular plan. We also wanted to include specific folding mechanisms, including hydraulics, but due to funding and other time constraints, we were not able to do that as well. Prior to the final design of the frame, as shown at the bottom right, we constructed several ANSYS models and SolidWorks models that we wanted to test before actual construction. To ensure that deformation was minimal and the damage to the frame was not something that we wanted to see, we wanted to make sure that the ANSYS models would give us the optimal results. Seeing here, the maximum deformation seen under applied loads from the Instron was about 2 millimeters, not much. So we decided that the frame would be good to construct using black powdered steel. And the structure of the frame consists of several unistruts for easy assembly. Now, as we dived into the finite element analysis of this frame, we had created a structure to hold the specimen undergoing testing. Now, the specimen would be held in a horizontal plane through here, and it would be secured by these clamps. Now, as the Instron machine applies loads onto this imaginary horizontal specimen, the vertical load would be applied downward, and the reactive force would be felt here, which would be pointing upward, hence these little pink arrows that we used for testing, which was our simulated applied force. Since we knew the reactive force would act upwards, this clamp would secure that specimen as much as the force acting upwards. So the more force that is being, the more the reactive force is, the more securely we can expect that piece to hold the specimen. Now, knowing this, we wanted to construct the final frame with the help of 10 feet unistruts that we needed to cut. And due to unforeseen circumstances that the team couldn't predict, we had to settle for a assembly instruction guide that we created, including step-by-step details for a future design team to execute, or we might want to execute that design ourselves. And with that, that is the explanation of our universal testing frame. Thank you for listening.